Hello, class. Hope you're having a great day. Today's lesson is 2.3 factoring polynomials. Let's just take a look at some warm-up questions from last day's homework. Question 6E was, are these two expressions equivalent? So what I'm going to do, ladies and gentlemen, is I'm going to take a look at the first one and expand it. So I'm going to write that since it's a trinomial squared, I'm going to write each trinomial individually. And then I'm going to, well, it's not FOIL, but I'm going to multiply every term in the numerator by every term in the denominator. So, sorry, I said that. Back that truck up, sorry. Every term in the first bracket, I'm going to multiply with every term in the second bracket. Okay, so it's going to look something funky like this. All right, so let's do that, ladies and gentlemen. So when you multiply through, I'm going to see that this is 16x squared plus 4xy minus 12x plus 4xy plus y squared minus 3y minus 12x minus 3y plus 9. Let's double check to make sure I've got enough terms here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. All right. Now I'm going to go and collect like terms, ladies and gentlemen. So I go from the highest power first. So I'm going to go 16x squared. Collect my xy. So it's going to be plus 8xy. I'm going to collect my x's, so I'm going to have negative 24x. Collect my y squareds, plus y squared minus 6y plus 9. Now you may say, hey, Mrs. R, should the y squareds go ahead? It doesn't really matter in this case. We're just checking for equivalency, and I'm just trying to compare it to the second equation, so that's why I did all the x's kind of first to see what they would match. So comparing my solution in the first one with the answer given in the second, I'm just going to check off my terms. Hey, the first term matches. The second term, however, look at the signs. It does not match. The third term also, the sign does not match. The fourth is okay, the fifth and the sixth. So even though this looks exactly the same except for two signs are switched, we're going to say that no, these are not equivalent. Just think there's a major difference between having a positive $1,000 balance in your bank account versus a negative $1,000 balance. Okay, so no, these are not equivalent. Okay, good. I know that was tricky because some people might say, hey, it's close enough, but no, the signs have to be exactly the same. All right, number 9, R, it said to simplify each expression below. Okay, so we're taking a look at surface area, and in this case we just have a complex situation. In the past you've had R being a complete value like 5 centimeters, but now we're letting it represent an algebraic expression. So to do surface area, I'm just going to move it over here. I'm going to do my substitution first, so it's going to be 2 pi times 2x plus 1 and square it, plus 2 pi times R, which is 2x plus 1, times my height, which is 2x minus 1. All right, now I'm going to do my squaring the binomial first. So I'm going to square the first, which is 4x squared, double the product. If you still need to do that on the sideboard, go 2 times 2x times 1. Okay, and you'll find out that that is plus 4x. If you still need to expand it and do an extra step, go ahead. And then square the last. Okay, so there's the kind of the first simplification, the first part of that. And let's take a look at the second part. Okay, I'm going to use FOIL here. So I'm going to go 4x squared. It's going to be minus, notice guys, it's going to be minus 2x and plus 2x. You can put that down, but it's also going to cancel each other out. So you didn't need to include it if you already saw that. And then minus 1. So what I was noticing here is that the negative 2x and the positive 2x cancel. All right, doing some distributive law, I'm going to have 8 pi x squared. And then I'm going to have plus 8 pi x. And then I'm going to have plus 2 pi. That's the first distributive law. Now I'm going to apply the second one. So I'm going to have plus 8 pi x squared and minus 2 pi. Notice the positive 2 pi and the negative 2 pi, they cancel each other out. So we're left with, together, combining like terms, I've got 16. That's a bad looking 16. Let me revisit that one. We're going to have 16 pi x squared. Okay, and how many pi x's? Plus 8 pi x left over. So there's your simplification. Likewise, for volume, pretty similar case for B. So volume equals pi. Again, we've got to do the r squared, sub that in, and times it by the height. Okay, so the height is 2x minus 1. All right, I'm going to square the binomial, so you're going to leave pi out front, so it's going to be 4x squared, because you square the first, double the product, it's going to be 4x plus 1 when you square the last, and then you still have to times that by its height, which is 2x minus 1, okay? And then we're going to take, I'm just going to do it a little different, ladies and gentlemen. I'm going to take, since this is a binomial, I'm going to take the first term in the binomial, multiply it by every term in the trinomial, and I'm going to take the second term and multiply it by every term in the trinomial. Okay, that's the order I'm going to go. Okay, so taking a look at this, ladies and gentlemen, I'm going to have 8x cubed plus 8x squared plus 2x minus 4x squared minus 4x minus 1. All right, then I'm going to simplify within my bracket, because I've got to collect some like terms. So I've got 8x cubed plus 4x squared minus 2x. Collect that and subtract 1. Constant stays the same. And my last step, ladies and gentlemen, is to use distributive law. So just multiply pi to every term. So it's going to be 8 pi x cubed plus 4 pi x squared minus 2 pi x minus pi. All right, so ladies and gentlemen, there you have 9, and we want to do one more, 10b, okay, and explain if these are the same, if these are equivalent. This takes a lot of work, ladies and gentlemen, when you've got a binomial cubed, okay? So the first thing I'm going to do is I'm going to do the first expression here, and I'm going to do the second expression on that side, okay? So because there's no quick way to cube a binomial, I'm going to expand it out. So I'm going to write x minus 3 times, okay? And I'm going to start with the second two second two binomials, multiply them through. So I'm going to leave the first one as is, okay? And I'm going to do this in a little shorter steps. So I'm going to say first, which is x squared. Outside and inside, I'm going to combine. So notice on the outside, I've got negative 3x, and on the inside, I've got negative 3x. So negative 3x and negative 3x is negative 6x. I'm just saving a line, ladies and gentlemen, and at a grade 11 level, you can do that. All right, and I apologize, you need to have your bracket around that. Okay, and then we're going to multiply every term in the binomial times every term in the trinomial. So we're going to end up with x cubed minus 6x squared plus 9x minus 3x squared plus 18x minus 27. Make sure you got 6 terms here. 1, 2, 3, 4, 5, 6. Awesome. Okay, and then finish off by collecting like terms. So we end up with x cubed minus 9x squared. Yep. Plus 27x minus 27. Okay, let's see how that compares to the other option. Now the other option is the same. We got to expand it out. And again, I'm going to focus on the second two binomials first. Okay, so what do we have here? When we expand it out, we're going to have 9 minus 3x minus another 3x is minus 6x and plus x squared. Okay. Then we're going to multiply every term in the binomial by every term in the trinomial. So I'm going to end up with 27 minus 18x plus 3x squared minus 9x plus 6x squared, running out of room, sorry, minus x cubed. Try to put that on one line, I just ran out. Okay, and you don't need that other bracket there. Okay, and let's collect like terms and put them in order. So notice here I've got negative x cubed plus 9x squared minus 27x plus 27. So are they equal to each other? Looking at the expressions, hey, it's darn close. Again, we've got the numbers looking the same, but the signs are different in many cases. So what you're going to do is say that x minus 3 cubed is not equivalent to 3 minus x cubed because the expressions are not the same. So therefore, they are not equivalent. Okay? All right, hopefully you enjoyed those warm-ups. Now we're going to do a review of factoring, and most of this should be similar to grade 10. So again, if you need any extra help after I do this lesson on factoring, please check the textbook because there's a extension in there on factoring just to get you ready, because I know it's been a while since some of you have taken grade 10 math. All right, so ladies and gentlemen, 2.3 factoring polynomials, and in many cases we're dealing with two different types of operations. When we take something that's factored and we expand it out, we call that expanding. But when we go with standard form and get into factored form, we actually do what's called factoring. So expanding and factoring are opposite operations. So you can choose to do the opposite to check your work. So since they are opposite operations, therefore check your work using the other method. Good. All right, so ladies and gentlemen, if you need help with any of these, you could also just Google it on YouTube or whatever and see plenty of examples of these, but I'm sure much of this will come back to you. Common factoring, what you're looking for is the lowest common factor. So what's the the greatest common factor? What's the biggest number that goes into all of your terms? So looking at A, notice that a 3 goes into all of them as well, but also notice that an M goes in, okay? So what we want here, ladies and gentlemen, is put your greatest common factor out front, which is 3M, and then you divide every term by 3M, and the leftovers go in your bracket. So it's going to be M plus 4 minus 5M squared, okay? That's common factoring. Okay, so you need the greatest common factor. And you always look to common factor first before you do the other factoring. So always try to common factor first. Okay? All right. Let's take a look. Factor by grouping. Now this is something that's quite often used in decomposition method, or sometimes it's expressed like this, where you've got 4 terms. So to recognize factor by grouping, in many times you're going to see 4 terms or a binomial that repeats itself. So to follow through this, I look at my first 2 terms and I say, hey, what's the biggest thing I can factor out of my first 2 terms? And looking at that, ladies and gentlemen, it's a k squared. So if I divide both terms by k squared, I'm going to end up with k plus 3. Looking at my last 2 terms, what's common there? A negative and a 2. So after I factor that out, I have a k plus 3. Watch your signs. Now notice here, ladies and gentlemen, we have a common binomial. So that gets factored out front. And your leftovers, which are your other multipliers, go in the other bracket. So it's going to be k squared minus 2. Okay? So this is what we call a common binomial. Good. Taking a look at B, notice that it's already partially factored for you, and hopefully you recognize that in each case you've got a y plus 2. So there's your common binomial, and your leftovers go in the bracket. Good. All right, simple trinomial. So ladies and gentlemen, for simple trinomial, remember it's ax squared plus bx plus c, where a equals 1. Okay? So that makes it simple. Okay? And we'll take a look at the first example here. So when we're doing this, and again, depends on how your teacher did it. I did product versus sum. So product for me is my C term. So product equals negative 40. Okay? The sum equals my B term, which is negative 3. So hopefully that's similar to what your teacher taught you. Okay? So what two numbers multiply to negative 40 and add to negative 3? Well, first of all, you should realize that if the product is negative, one needs to be positive and one needs to be negative. Okay? So I could do 1 times negative 40. I could do 2 times negative 20. I could do 4 times negative 10, or 5 times negative 8. It could also be that the smaller number is negative. Negative 1 times 40, negative 2 times 20, negative 4 times 10, and negative 5 times 8. At a grade 11 level, ladies and gentlemen, I don't need to see all these, but if you need to put them down so that you can narrow down which one is going to get you, notice that all of these are the product of negative 40, but which one actually sums to negative 3? And in this case, it is this one. If you're looking for a shortcut how to reduce these numbers, ladies and gentlemen, notice that we realize that one has to be positive and one has to be negative because the product is negative, right? However, the sum is negative. That tells me the largest number has to be negative. So that automatically cancels out that column. So if you think logically about it, you can just narrow it down to the biggest number having to be negative, and then you search through. Again, you don't need to show me this all as long as you show me the one correct factor that affects that. And when we take a look at doing this, we square root the first, so it's going to be x in the first, and then we take the signs within our two factors, so it's going to be plus 5 and minus 8. All right. Taking a look at example B, although, ladies and gentlemen, you notice that simple trinomial means a equals 1, but in this case, a equals 3. So what we always want to try to do here is remember common factor first. So looking here, how could I tell to try to common factor? Because a does not equal 1. So we're going to notice that 3 can go into all the terms. So we're going to take out a 3, and we're going to be left with x squared plus 3x plus 2. Now notice that we are left with simple trinomials because now a equals 1. So our product in this case is going to be 2, and our sum in this case is going to be 3. So it's an easier one. What two numbers multiply to 2 and sum to 3? 1 times 2. So leave the 3 out front, and then you're going to go x plus 1 times x plus 2. And that's factored. All right, now we're going to get into what's called difference of squares. Okay, the easiest thing is to remember what to recognize this is. First of all, if we have a difference of squares, first of all, it's got to be a binomial. Difference means you have to have a subtract sign. And we also have to have perfect squares. Okay, so noticing the first one, hey, it's a difference, meaning there's a subtract sign, and of perfect squares. So what I do is I automatically set up two brackets. I know with difference of squares that I need to put a positive sign in one and a negative in the other, because notice it's not a trinomial, it just has the first and the last term if you were thinking of a regular trinomial. So the middle term is going to cancel. So if I take the square root of the first, which is x, and x, take the square root of the last, it's going to be 4 and 4. If I tried to check this, ladies and gentlemen, I'll just show you how to do this quickly. If I try to do my check, I do my FOIL. I'll start with my answer first. And then I'm going to do my FOIL. So it's going to be x squared minus 4x plus 4x minus 16. So notice, ladies and gentlemen, this is why we need to have one plus sign and one negative to delete those two terms to get you to your final answer, which is x squared minus 16, which is your, sorry, to get to your, back to your original question. Okay, so that's why I always put a positive sign in one and a negative in the other. Now, looking at B, first as it is, I don't see perfect squares. But remember, we're always going to try to common factor first. So let's do that. What number goes into both 75 and 3? That is 3. So it's going to be 3 times 25p squared minus 1. All right, so leave the 3 out front, and then we're going to realize that this is a difference of squares. Put a positive sign in one, negative in the other. Doesn't matter which one goes first. Okay, take the square root of the first term, so that's going to be 5p, and the square root of the last. And there you have it, ladies and gentlemen. Good factoring. Almost done. We saved the hardest for last, but some people get this method and, you know, it's not a big deal. Decomposition is used when a does not equal 1, so it's a trinomial. Okay? And remember, if a doesn't equal 1, therefore we're going to split the middle term and then factor by grouping. And because we have to do this a little different, just remember, guys, that the product in this case equals a times c. It actually always equals a times c. If I back up here, ladies and gentlemen, when a equals 1, it's still a times c. We just always just say it. We always look for the c value. Okay? So remember, product is a times c. That's my biggest mistake when people do decomposition. They forget that. All right? So we always try to common factor first when we can. Okay, so let's start off with the first one here, a. We could take a 2 out of every term. So let's do that. So leave the 2 out front, and we're going to divide everything by 2. So you're going to have 6x squared minus x minus 1. And then notice that this is decomposition because a does not equal 1. A equals 6. So in this case, we're going to do our product. So product equals 6 times negative 1. I'm going to put that step in to remind you guys. So that equals negative 6. And our sum is still the same, negative 1. That doesn't change. Okay? So we notice, ladies and gentlemen, the product is negative, which means one's got to be a positive, one's got to be negative. And the sum is negative, which means the biggest number has to be negative. So I could either go 1 times negative 6 or 2 times negative 3. Looking at that, the only one that makes a sum of negative 1 is our second expression. So instead of writing it in normal, we're going to split the middle term. So let's write everything else the same. So it's going to be 2, 6x squared. I'm just going to give me a sec here, and I'm going to go minus 1. So I'm going to split that middle term into 2 terms. Okay? So it's going to be plus 2x minus 3x. Okay? Notice, ladies and gentlemen, that I've still kept the equation balanced, because if I take 2x and subtract 3x, it's negative x. Okay? Now what I'm going to do, ladies and gentlemen, is I'm going to group factor by grouping. So look at the first 2 terms. Okay? And what's common there, and I'm going to put a big bracket here just to help me out. Okay? So we got 2x that's common. What's left over when we do this, ladies and gentlemen? We have 3x plus 1. When I look to group the last 2 terms, what's common there, ladies and gentlemen? Negative 1. So I put the negative 1 down. What's left over? 3x plus 1. All right. Notice, ladies and gentlemen, Notice that I see a common binomial of 3x plus 1. And after you've done that, the leftovers become the next factor, which is 2x minus 1. When you're doing decomposition, ladies and gentlemen, you should end up with a coefficient in front of at least one of the x's, if not both of them. Okay, that's what decomposition makes it happen, okay? All right, let's try one more of these. And if you want to try it on your own first, see if you can do it, pause my video, give it a try, and then unpause my video and check it out. By all means, go ahead. But here we go. Trying to common factor, ladies and gentlemen. We can't common factor, so we're going to go right to decomposition. So my product equals 2 times 6, which equals 12. Okay? And my sum equals 7. Okay? So we could do 1 times 12, 2 times 6, or 3 times 4. Again, you don't need to write them all out. I'm just doing it for those that need the help. And which one is the sum of 7? 3 plus 4. 3 times 4. So we're going to split that middle term. So what's this going to look like? Okay, this is going to look like 2x squared. And then I'm going to go plus 3x. And I'm going to go plus 4x. And plus 6. Now, ladies and gentlemen, just as a side note, if you did 4x first and then 3x next and you're checking with a buddy, you're going to end up with a final answer. So if I back up here, ladies and gentlemen, notice how the way I did it, I was grouping the 3x plus 1. If your buddy did it the reverse way, they would be grouping 2x minus 1, and then their leftovers would be the 3x plus 1. So you'll arrive at the same answer. So please don't be concerned if your neighbor or friend is doing it with you, gets a different in-between solution, okay? Or starts, this next line looks a little different, that's fine. Okay, so what's common in the first two terms, ladies and gentlemen? I've got an x, so what's left over? 2x plus 3. And what's common in the last two terms? A 2. So what do we have left over? 2x plus 3. Factor by grouping, 2x plus 3 times x plus 2. And there we have it, ladies and gentlemen. Okay, hopefully that's a good review, ladies and gentlemen. It's important that if you haven't got that figured out, that you work with it, because we have our quadratics coming up where we're going to be doing operations. And just remember, guys, that factoring is used to change it from standard form to factored form that allows you to solve, right, or find the zeros. Okay, so that's where we're heading with that. Here's your homework, page 102, numbers 1, 3, 4A, B, C, D, 5 to 7, and 11. Have a fabulous day, guys, and good luck on the homework.